Hi there, this is Dr. Sisonia, Assistant Professor in Chemistry, SNS College of Technology. Today we are going to see a video on the estimation of hardness in water. From the unit Water and its Treatment, it is a syllabus of Chemistry of Engineering Materials. Now let's go for the topics. So estimation of hardness of water. There are different types of estimation of hardness of water by various methods. Then there is a method called EDTA method, preparation of solution. So we are finding the hardness, that is the temporary hardness, permanent hardness, and the total hardness of the water using EDTA solution. That is ethylene diamine tetraestic acid. So, and also we are going to see about the calculations in the next video. So estimation of hardness of water. So as I already said, it can be determined using the EDTA method. And another method is alkali titration method and also soap titration method. So we do not use this alkali titration and the soap titration commonly. We are interested in using the EDTA method, which is widely applied and used in the laboratories. So we can discuss in this session about the determination of hardness by using ethylene diamine tetraestic acid. So how do you estimate the hardness of the water by the EDTA method? It's actually the EDTA that we're using for finding out the hardness. It is complexed with the hardness causing minerals that is present in the water. So it is a complexometric method and it is more accurate, convenient, and fast method. So this is the commonly used method for the estimation of hardness of water. So you can see the structure of the EDTA. So you have four acid. It's actually hexadentate ligand. Okay, so this there are different unique properties of this EDTA. That is, EDTA is insoluble in water. So it is the disodium salt of EDTA is soluble in water, but EDTA has such as insoluble in water. It is used as a complexing agent. So EDTA forms stable complexes with the magnesium and the calcium ions of hard water. So as I already said, EDTA is a hexadentate ligand because EDTA structure has a nitrogen and four acids. Here hexa, which can take away the electrons or take away any kind of negative ions from a metal or any other electron-rich substance. So it is a hexadentate. It binds the metal ions in water. That is, it binds for the calcium and the magnesium to give highly stable chelate complex. These metal ions are bonded via oxygen or nitrogen from the EDTA molecule. So nitrogen, you have two nitrogen and oxygen is present in EDTA, which helps in attaching the metal ions. So this type of titration, it's called as a complexometric titration method. So estimation of hardness of water using the EDTA is the complexometric titration method. So you can see the formation of the metal ions, that is the complex with the EDTA and this reaction. You have the metal ions, okay, the metal ions of 2 plus valency. When it reacts with the ethylene diamine tetraacetic acid, it forms a coordination bond with the metal. So there's a complex formation of the metal. So ionic bond, which are made up of ions. So positive ions or negative ions will attach each other and form a ionic bond. So covalent bond, that is made by two different atoms. So both the atoms are very similar in electropositivity or electronegativity. Shared electrons and form a bond called the covalent bond. So what about the coordinate bond? These coordinate bonds happen between the metal atoms and the ligands. These bonds are shown in the structure. So this EDTA react with metal ions and form complex. Thanks for watching. We'll see the rest, how the properties of EDTA in the upcoming video.